Hey, good morning, everybody. We'll get started here in a few minutes, letting folks finish their logging in process. We always have updates to the webinar applet and whatnot. But if you're looking for a local agency traffic safety academy webinar, you've come to the right place.
And while you're waiting, if you want to go ahead, there's 5 things in the download pod. You can start downloading those if you're interested. The one that says Road Safety Fundamentals with my last name, Hagen, that is the full page slides of the presentation. The one underneath that where it says notes is the notes format of the presentation. And so you can download that if you want and follow along, take notes if you want to print that out real quick. Underneath that, the one that says Road Safety Fundamentals is the Road Safety Fundamentals document. It's a big Federal Highway Administration document, and so you can download that one there. Then beneath that, the one that's FDOT, and then it says 2016 SHSP is the Florida DOT Strategic Highway Safety Plan. You can download that. And then if you're going to want your PDHs for attending this, there is a Word document that's the LATSA PDH request form, and go ahead and download that. And at the end, you can fill that out.
Great. Also, today's webinar is kind of in modules as Larry goes through the presentation. So if you can write your questions, if you have any along the way in the question pod, I'll be moderating the questions, and we will kind of hold for questions in between each of the sessions, and then have a general Q&A at the end. So we'll be answering questions both at the end and along the webinar, depending on which question it is and when it comes in. So if you have questions, please type them in there. Also, if you can do me a favor, we didn't set up a poll question like we have in the past. This is the first one of the year. We kind of want to get a quick little how many people are in the room with you. It might be included in the post email that you receive on the survey. But if you can type into the chat pod how many people are in the room with you, including yourself. So if you're by yourself, just type 1. And if you've got 2 or 3 people, then it's them plus you. Just so that we like getting a sense of how many people do this by themselves in their office versus in a conference room with their buddies. Did we begin the recording already? Yeah, auto recorded. Okay. Yeah, it's about 5 minutes past the hour, so I think we'll go ahead and begin. Most people that are logging in are already here. So welcome to the first of the LATSA webinars for 2020. Today's presentation is on road safety fundamentals. The presenter is Larry Hagen from Hagen Consulting Services. You have in your email that had the link to get to the location where you are here, the link to the Tampa Bay Traffic Safety site that has the recordings from past webinars. The recording from this webinar will be posted there as well. As Larry mentioned as well, in the handout little module of the GoToWebinar window, there are 5 handouts. There's the presentation that Larry has given in both full screen and in note view. There is the PDH request form and also the Roadway Safety Fundamentals publication. Larry, what was the 5th document? I only mentioned 4 just now.
The 5th one is the FDOT Strategic Highway Safety Plan.
The Highway Safety Plan. Yes. So Larry Hagen of Hagen Consulting Services, a very large one-man firm, has lots of experience, over 30 years of experience doing transportation engineering work in the state of Florida, is very knowledgeable on the subject. He's going to go through this presentation on the roadway safety fundamentals. With that, I'm going to mute myself and moderate the chat. Anybody has any questions, please type them on there. And Larry, take it away, please.
All right, thank you, Anthony. Well, welcome to Road Safety Fundamentals. The Road Safety Fundamentals is a textbook that was prepared by Federal Highway Administration. One of the things that Federal Highways had determined was that there wasn't a really comprehensive training resource for people entering the road safety field. And so there was a gap there that needed to be filled. And so they created or produced the Road Safety Fundamentals textbook. It was, I believe, part of a NCHRP study where they were trying to assess what are some of the things needed to really help build a culture of road safety. And so the Road Safety Fundamentals publication was released in November of 2017, so it's just a couple years old. It's fairly current. One of the things you'll see my name there, Larry Hagan, and at the end is RSP. That's a road safety professional. I'm a certified road safety professional. That's a recent certification that was developed through the Institute of Transportation Engineers. I also have listed there Rudy Ums. If you've never met Rudy, you've really missed out. Rudy's a great guy. He spent 40 years in the Office of Safety with Federal Highway Administration. And when I first created some of the slides, I sent them off to Rudy, and he added a lot of really good stuff to make this presentation even better. Rudy's not on the call. I believe today he's doing something much more important. He's spending time with his grandkids, but Rudy certainly added a lot to really make this presentation better. And so I wanted to make sure I do a great shout out to Rudy. Well, under Road Safety Fundamentals, the picture that you see on your screen, what it says for this document is concepts, strategies, and practices that reduce fatalities and injuries on the road. And that's what the publication is about, introducing concept, strategies, practices that will help reduce fatalities and injuries on the road. And my goal here in this webinar is to add value to you, hopefully, as a transportation safety professional by introducing you to this resource. And I hope that by the end of this webinar, something has clicked with you. You say, gosh, that was good. I want to go and learn some more. And you'll grab this resource and learn more things that will help you to make our roadways safer for everyone that travels on our roadways. And so I hope that you learn a lot through this webinar. But again, this is going to be just a real high level overview. There's a whole bunch of stuff in this textbook, and it's very fundamental, but it points you to other resources where you can really learn more and study more. So I encourage you to download the document. It's there in that handout pod. So download the document, and it's a PDF. You can print it out and put it on your bookshelf. Yeah, it's interesting. The main author, if you will, or the project manager for Federal Highways is Felix Delgado. Felix used to be the district safety engineer in District 4, and then he moved up to Tallahassee, worked in the division office in Tallahassee, and now he's with Federal Highways in the Washington, D.C. office. And again, he was the project manager for this publication. So again, I hope you get a lot out of this, and let's jump into this. But before I jump into it, I always put my standard disclaimer when I do one of these webinars, because basically my disclaimer says this is going to be relatively short, high-level stuff. You're not going to be an expert, but hopefully I give you some information and I give you the resources so you can dig deeper yourself if you really want to study and understand this material. So again, you're not going to be an expert in all these things just by virtue of coming through this webinar, but hopefully, again, it's going to just point you to some resources, point you to some information so that you can study it more and become an expert. And again, apply these things to make our roadways safer. Now, one of the things, before I get too much deeper into this, the road safety professional certification that I mentioned, this is one of the resources that is recommended for if you're pursuing RSP certification. This is something you definitely want to get and study and read through, because there's a lot of great material in here, and it's organized and presented in a way where it is accessible. So again, a resource I highly recommend. Everybody that's doing road safety work should have a copy of this on their bookshelf. Now, the the Road Safety Fundamental document is broken into 5 different units, and we're going to cover these units, like I said, fairly briefly. Unit 1 is the foundations of road safety, and so we'll talk about the context of road safety through the years, multidisciplinary approaches, and then we'll talk about the road users. Next, we'll look at understanding human behavior and changing human behavior, because certainly human behavior has a huge impact on road safety. You know, most of the crashes have some element of human failure or human error built into the crashes, and so certainly looking at human behavior is an important part of road safety. Unit 3 is going to be on measuring safety, and we'll talk about safety data, the importance of safety data, the types of safety data, and things we can try to do to improve the quality of safety data. Unit 4 is going to be how do we solve safety problems, looking at the road safety management process, looking at site level safety management and system level safety management. And then Unit 5 is now implementing these road safety efforts. Who does what? We'll talk about road safety research. We'll talk about strategic communications, and then look at advancing road safety and where we go from here. And so those are the 5 units that are covered in the document here. So we'll begin in Unit 1, the foundations of road safety, and the real objectives, the learning objectives, if you will, for Unit 1 is to describe the importance of road safety, how it relates to public health, economic, environmental, and demographic trends, to recognize the roles and responsibilities of various disciplines and approaches to improving road safety. We're going to talk about the difference between nominal and substantive safety. We'll identify some of the key points in the history of road safety in the U.S., including some of the key legislation and agencies, and understand how all these things have shaped today's roadway safety environment. And then we're going to look at different groups of road users and different challenges that are unique to each of those groups. All right, so what is safety? How do we define safety? And well, safety can be defined as the absence or risk of danger. Certainly in the transportation realm, the ability of a person to travel freely without being injured or dying. A perfectly safe transportation system would not experience any crashes at all. That's certainly a long way from where we are. But we typically measure roadway safety in terms of the number and severity of crashes that are experienced. But again, our goal as safety practitioners, as we try to make roadway safer, is that everyone gets home at the end of the day. At the end of the day, everybody's able to make it safely home and enjoy time with the people that they care about, the people they love. All right, so let's jump into Chapter 1, the foundations of road safety, and look at the context of road safety. This is, again, straight out of the book, the statistics here. An average of 37,000 fatalities per year in the United States on our roadway system. 37,000, that's a lot of people. And so it is something, again, we take it kind of for granted. We don't talk about it a whole lot until there's a big crash or something like that. You know, there's been a lot of news the past few days about the helicopter crash where, you know, Kobe Bryant and his daughter passed away, you know, and that was 8 people. Well, we kill a lot more people than that on our roadways every day, and it doesn't get that much press. 37,000 fatalities per year in the United States. That's a lot. And 2.3 million injuries in motor vehicle crashes each year. And again, that's a lot of folks injured, a lot of impact on people's lives. And again, can we do something to change that? Now, when you look at this graph, you can see how back in the late 80s, the numbers were peaking up pretty high, and we've dropped it down some. Over the last few years, it dropped a little bit more, but then it's trending back up again. So we need to continue to push it down, especially if we want to get anywhere close to the vision 0, where we have no fatalities. And so again, that is where we want to be, but we're a long way from it when you've got, you know, 30,000 plus dying on the roadways each and every year. This is an interesting figure, and again, there's 100 squares, if you will, in that little chart, and it gives you a breakdown, if you will, of who it is that's being killed on the roadways. And so the green squares are vehicle occupants, either the driver or passenger inside a vehicle. The yellow squares are pedestrians, and then the dark gray squares, motorcyclists. You see just a couple squares there for bicyclists, and then the last square there, the white one, for other or unknown. So that would be other things, you know, the e-scooters or, where they just don't record who it is or what happened there. But anyhow, you can see it impacts all of road users. And again, there's just, you can see the breakdown of the fatalities. And, pedestrians are a significant portion of it. Bicyclists, not quite so much. They're just typically like 2%, but still we can do a lot more to protect pedestrians, motorcyclists, bicyclists, and motor vehiclists. And so that's our job as road safety professionals, is again to protect all users, keep all users safe. It's really interesting when you consider the fatality rate, because we have so many vehicles and they're traveling so many miles. It's so easy to travel, with our interstate system and the just the great facilities that we have. It's easy to travel. I travel a lot, and may travel 400 or 500 miles a day sometimes to go to different places, and we travel many, many miles. But we've been so successful in making our cars safer and making our roads safer, we've dropped the fatality rate per 100 million vehicle miles down to where it's about 1.0 fatalities per 100 million vehicle miles. And you can see back in the 60s, it was up over 5.5. And so imagine if we had 5 times the fatalities that we have now. So instead of 37,000, close to 200,000. That would be just a national disaster. That would be terrible. So it's good that our rate has declined, but the bad news is our rate of decrease is declining, that we're kind of bottoming out. And so we need to really come up with some new treatments, some new thinking to continue to push that down. Because again, 1.0 sounds real good. 1 fatality per 100 million vehicle miles of travel may sound pretty good, but still 37,000 people is a lot of people dying each year on the highways. And so we still got a lot of work to do. And again, the only way we do it is working together and sharing information like this, learning and applying what we learn to make our roadways better. Now, if you learn nothing else, we need to understand the difference between nominal safety and substantive safety. And again, if you learn nothing else from this webinar, I hope you grab hold of this, because this is really important, and it is a different way of thinking than what we traditionally think. Nominal safety is just meeting the standards. And I always think of nominal safety, one of the really classic examples is clear zone width. And if you have something that's outside the clear zone, it's safe. But if it's inside the clear zone, it's unsafe. And that's nominal safety thinking. And reality is, it's not like that. So let's say you've got a freeway facility and a 36-foot clear zone. Well, if you have a tree that is at 36 feet 2 inches, that's really no difference than a tree that might be at 35 feet 10 inches. Really the probability of that tree being hit is very, very close. And so in one case, okay, I'm 2 inches outside the clear zone. In the other case, I'm 2 inches inside the clear zone. In one case, you say, gosh, that's unsafe, it's inside the clear zone. And oh, the other situation, oh, that's safe, it's outside the clear zone. And from a real perspective, what you would really experience in terms of real crash experience, there's virtually no difference in that. And that's one of the things, it scares me a little. What are we doing for our future when we're doing a lot more landscaping now on freeway facilities, and we're putting trees in places where there are no trees currently, but we're putting it, okay, well, just a couple inches outside the clear zone. Are we possibly making it less safe? And again, that's something as transportation professionals, we need to have that conversation and discuss that. And so again, nominal safety is what you see there, a step function. Okay, we're inside the clear zone and the crash risk is high. We reach that magic 36-foot clear zone length, and we're much safer, much less crash risk. But again, that's not reality. And substantive safety, as shown in the yellow line you see on your screen, is really the substance of safety, and it's measured by real crash experience. And so, again, we really need to be thinking this way, that meeting the standards is not good enough in and of itself. We need to go beyond meeting the standards to, are we really providing a safer roadway environment? Are we doing the best we can to make the environment as safe as we possibly can? All right, so that's really the context of road safety. The next, we're going to jump into chapter 2 here, road safety through the years. And Rudy really contributed a lot of good stuff here. The chapter in the book talks about the development of road safety programs, and we've got some data here going way, way back into the early 1900s. And so you look at 1921, the first year shown there where they have all the data across, 55 billion vehicle miles traveled, 13,000 deaths, the fatalities per 100 million vehicle mile there, 24. And again, currently we're like at 1. So imagine again, 24 times the fatality rate. That would be something critical. And so it's good that we have reduced that fatality per 100 million VMT way down. And it's great that we've come from 24 down to 1. But again, we've still got a long, long way to go if we're going to get anywhere close to Vision Zero. And great thing working with Rudy, it talks in the book about this first national conference on street and highway safety held back in the 1920s. Now, Rudy wasn't there, I don't believe, for the conference, but when he was at Federal Highways, in the archives there at Federal Highways, they had the notes, the handouts from this first ever national conference on street and highway safety. And Rudy's got some pictures in here from the handouts from that 1924 conference, and great history here. And you can see at this level, it's the Secretary of Commerce, Herbert Hoover, who later went on to be president, and President Calvin Coolidge are coming to this conference. It was something of national importance. We got to have this huge conference on street and highway safety because people are dying on our highways. And so again, back in the 20s, it was 13, 14,000. Again, we're at 37 to 40,000. It should be something we talking about at the national level as well. But in this first conference, you can see some of the people and organizations that were there: AAA, American Electric Railway Association, American Mutual Alliance, the American Railway Association, Chamber of Commerce, and all these other organizations were a part of this discussion. They wanted to be a part of this because it was something nationally that was a crisis that we needed to pay attention to. And the meeting began with an address from the President of the United States. The Secretary of Commerce had an opening address, and then all these different agencies, federal government, state government, municipal government, planning, the grade crossings, so talking about railroad crossings, all these other things were part of the conference. And so you can see how traffic safety is beginning here at the national level, the first real conference where they're starting to say, hey, we need to talk about these things and work on these things together if we're going to reduce that fatality rate on our roadways. They went on to talk about the administrative and regulatory principles here, the uniformity, statistics, crash reports, spot maps, surveys, and so forth. And so you can see it was a very comprehensive conference and web or study they were doing there to try to get our thoughts focused on making our highways safer. And then they come up with suggestions for cooperative work, different associations, unofficial organizations, something, the automobile manufacturers had work to do, insurance companies had work to do. And so lots of different people, a multidisciplinary approach is, we still talk about that today, a multidisciplinary approach to this. And again, this is the foundation. This is how we started trying to make our highways safer. A little bit later, 1954, a White House conference on highway safety. So again, it's at the presidential level saying, hey, we got to do something to make our roadways safer. We need to do something nationally to improve the safety of the transportation experience in America. Then it continued in 1966, President Lyndon Johnson signing this National Traffic and Motor Vehicle Safety Act of 1966. and the Highway Safety Act of 1966. So you can see it's over the years, all the things that have gone into creating what is the Federal Highway Administration, the NHTSA, and all these other things, and the Federal Highway Safety Program. And the book gives you a nice timeline of some of the different things that happened. 1893, the Office of Road Inquiry is created, would eventually become FHWA, the Federal Highway Administration. And it's not until 1908 when the Model T is released, the first automobile, due to what Henry Ford did in terms of the assembly line and mass manufacturing. It's now affordable. Before 1908, before the Model T, only the really, really rich folks could afford cars. Everybody else was on horse and buggy and those kind of things. So 1908, the Model T is released, and more people, the middle class, got to enjoy, automobile transportation. And you can see as we go through the years, the Bureau of Public Roads is created, the first national conference that we mentioned, 1924, and Uniform Vehicle Code, 1926. And so you can see all the history leading up to, again, where we are now. The first gas tax, 1 cent per gallon in 1932. 1944, Congress approves the development of the National System of Interstate Highways. That's an interesting story in and of itself when you start really seeing where the interstate system came from. Basically, it was a big push by Eisenhower. And, when he was, I think, a corporal or something early in his military career, he was charged to take a convoy across country. And the connectivity of the roads back then, when he was just a youngster in the military, was terrible. And he would go from state to state, and some of the roads, there'd be asphalt for a while, then they'd turn into dirt roads, and then they'd suddenly end in some field somewhere. And so he'd have to turn around this big, huge convoy of military vehicles carrying all this stuff, turn it all around, backtrack to find another road to connect. Because, certainly back then you didn't have Google Maps or anything like that leading you. And so as he went from state to state, the roads didn't really connect real well. And he remembered that. And when he was in World War II and saw some of the highways in Germany and how well connected they were and how easy it was to move troops and equipment, he said, hey, this is something we really should bring back and bring to America. And so the National System of Interstate Highways originally was largely designed to move troops and equipment in preparation for war. But again, you can see how much it impacts our lives today. Being able to travel on nice interstate facilities and go quickly from place to place certainly has impacted our lives drastically. And then you can see again, as we continue on, 1956, the Federal Aid Highway Act provides dedicated funding stream to support the interstate highway system. And then we start beginning in 66, Highway Safety Act, and we start really starting to address highway safety, motor vehicle safety acts. And, 1971, the first federal safety standards requiring child passenger restraints. So we're starting then in the early stages to build a culture of safety. In 1973, oil embargo leads to the energy crisis and the national maximum speed law. Some of you may be old enough to remember when 55 was the maximum speed limit on the interstates, the freeways in America. 1974, motorcycle helmets, first safety standard requiring motorcycle helmets is passed. And then as we go on and on, iced tea is passed, gas tax increased up to 18.4 cents per gallon. I believe that's the last federal gas tax increase that we've had. 1995, we repeal the national maximum speed limit, and so the states raise their speed limits. T21 is passed 1998. Safety Lou is passed in 2005. 2012, MAP 21 is passed, which brings us up to our current level of federal legislation, and again has done a lot in MAP 21 and Safety Lou. Those federal legislation did a whole lot to improve traffic safety. and had a lot of funding specifically for safety programs, again, focused on making our roadways a lot safer. All right, chapter 3 gets into multidisciplinary approaches. And chapter 3 talks about the 4 E's of safety. If you've been around safety for any length of time, you hear about the 4 E's of safety: engineering, education, enforcement, emergency response. And there is a 5th E, and in the text it talks about the 5th E being evaluation, that you evaluate your program and then continue to refine it. Well, I think, each of those 4 E's should be doing their evaluation, how well their program is doing. I like to think of the 5th E as everyone else, because it doesn't matter how well we engineer it, how well we educate people, how severely we enforce it, and how great our emergency response is. It really doesn't matter that if the people aren't doing their job, the drivers, the pedestrians, the bicyclists, if they're not thinking safety as well, our system isn't going to work well. And so really, I think the 5th E should be everyone else. And I did a webinar a year or 2 back, I think, on the 5E approach to safety. And again, talked about that 5th E, which is everyone else. And again, we can do all the engineering we can, but if the people don't know what to do with what we engineer, don't know how to respond, or ignore it, then we haven't really done anything. And so we got to get everyone on board if we're going to get anywhere close to, vision 0. Multidisciplinary approaches, it talks in the text about targeted enforcement, and this is something that certainly is a useful thing for the enforcement agencies to do. They get out and to enforce the pedestrian safety laws, a plainclothes policeman will step out and see if the vehicles actually yield to them or stop for them, and they can either cite or warn the vehicles that don't stop for them. The one thing you have to do if you're going to do that kind of approach is make sure you do give the vehicle that's approaching adequate stopping time, because if you just step out and you haven't given them enough notice that you're stepping into the crosswalk and they physically can't stop, you've really entrapped them. And so you want to make sure that when you do this, the vehicle is far enough down the street based on the approaching posted speed that they actually have time to react appropriately. And so it's something you have to do carefully. You can't do it willy-nilly. You have to know what you're doing. But again, it is a useful tool for the law enforcement agencies to help people understand their responsibility as drivers to yield to pedestrians in uncontrolled crosswalk like that. One of the other things, the Click It or Ticket campaign, it's a national campaign, and it really brings awareness to seatbelts, that seatbelts are required in most states, I think all states now. Seatbelt use is required, and it does really help the survivability of crashes if you are wearing your seatbelt. And so again, the Click It or Ticket campaign is all about just being visible and getting people's attention to, hey, go ahead and buckle up. And it is something, like I said, it's a national thing. You see it all across the nation. Click It or Ticket, and you'll see it on the dynamic message signs as you're driving down the highway, and the police will get out there, the highway patrol will get out there and enforce it. And we also want to mention Florida's Strategic Highway Safety Plan. One of the things in the history of the safety programs is that all states now are required by federal highway to have a strategic highway safety plan. And that was one of the things also in the download pod was Florida's current strategic highway safety plan. And again, we want to approach this strategically in a multidisciplinary approach, really trying to do all that we can, all the different people rowing in the same direction to try to reduce the number of crashes and reduce the severity of crashes on our highway system. And in Florida's Strategic Highway Safety Plan, if you haven't studied it or ever looked through it, again, just download that document, take a look through it. Florida has adopted these 13 emphasis areas. And lane departures is the first one, impaired driving, pedestrians and bicyclists, intersections, occupant protection, motorcyclists, aging road users. That's certainly something we have to pay a particular attention to in Florida. We have a growing proportion of our population is over the age of 65. And as people age, there are things that naturally occur to all people as they age, and it impacts how we should design and think about our roadway system. We also have commercial motor vehicles, speeding and aggressive driving, teen drivers, distracted driving, work zones, and traffic records and information systems. So these are the 13 emphasis areas identified in Florida's Strategic Highway Safety Plan. And again, there's a lot of work to do in each of those emphasis areas. And for each of those areas, there's particular strategies that are being employed to try to reduce crashes in that particular emphasis area. All right, chapter 4, let's look at the road users. Road users includes people like passenger vehicle drivers and occupants, drivers of trucks and large vehicles, motorcyclists, pedestrians, bicyclists, and certainly others. You can include things like e-scooters, skateboarders. There's lots of other things that are out there that are road users that use the roadways for transportation. And each of them has different needs, different things that we may have to do to accommodate them. And one of the things I always like to say when talking about roadway design is all of the road users, whoever they are, should know when to go, where to go, and how to go. That should be really clear. It should be something they understand when they're supposed to go, where they're supposed to go, and how they're supposed to go. And they should understand that in the context of, the roadway environment around them should give them clear information, how fast they should be going, where they should go, at a traffic signal, when it's your turn to go, and those kind of things. And so if we're going to have all these different people operating together in our road system, they need to know where they belong to be, where they should go, when they should go, and how they should go. And so that's an important part of really doing good design, is making sure that we really communicate clearly to the road users how they're supposed to use the road. Now look at this road here. You see the picture of the road here. The intended posted speed of this roadway is 35 miles an hour. But if you got nice wide lanes, nice shoulders, you've got this center two-way left turn lane that again gives you a little more freedom to maneuver. Do you think people are really obeying that 35 mile an hour speed limit? Well, a lot of people would probably be driving a lot faster unless you're out there doing a lot of enforcement activity and really ticketing people for driving too fast. What we typically see is, again, if you have big, 12-foot lanes all the way across, nice shoulders, nice roadside environment, people are going to tend to go a little bit faster than whatever that posted speed, unless you also have a sign posted out there, welcome to Waldo or something like that. That might actually reduce the speeds. But other than that, people tend to drive a little bit faster than what's typically posted. One of the things you can do, though, is implement a road diet. This was a location, and let me see, what was it? This location out west. And what they did here, this is in Seattle, and you can see before you've got, lane lines. The picture to the left is the before, the picture on the right is the after situation. You can see in the left, you've got a couple lane lines. It's a 4-lane undivided section there, and there's really a lot of ambiguity for the vehicles where they should be, and do bikes fit here anywhere, and a lot of questions there. And so what they did was the traditional road diet, probably the most common one talked about, is a 4-to-2 conversion, basically, where you have a 4-lane undivided roadway and convert it to a 2-lane roadway, one in each direction with a center 2-way left turn lane, and then gives you pavement width to provide bicycle lanes. And in this case, they got parking now on the roadway as well. And what they found by going to this road diet here at this location, that it there resulted in a huge result, or a huge decrease, I'm sorry, in the 85th percentile speed. That really kept basically the same roadway capacity. The number of bicyclists on this corridor increased 35%. Pedestrian crashes declined by 80% by what they did here in this road diet. And so it made it a whole lot safer, made it better for all the road users. They know now where to go, when to go, and how to go. And so it created a better environment for all the road users, and again, greatly improved the safety without really losing any capacity. Because typically in the 4-lane undivided section, what happens is you get one left turn vehicle in that leftmost lane, and it really wipes out the capacity, the through capacity of that lane, that one left turning vehicle waiting for a gap in oncoming traffic. And so you really end up with typically one lane in each direction of real throughput capacity. And so going to the road diet didn't really diminish the capacity, but greatly reduced 85th percentile speeds, made it better for bicyclists and much better for pedestrians. All right, now before we get into Unit 2, I'll pause here. And are there any questions in the chat, Anthony?
There are no questions at the moment. I will give folks maybe a second to see if there's anything that they want to add.
Yeah, like I said, the book is broken into 5 units, and so I'll pause as we go from unit to unit and see if there's any questions, just so we don't get too far ahead of any question.
I mean, a comment or a question that I had while we give people a chance to look at that. As you were going through the timeline of the events and kind of the major items that have happened, have you ever seen anybody try to correlate or map those against the fatality trend across time to see, if there's been any dips or any correlation whatsoever to, when the national speed limit, increased, or was there like a slight spike in the, fatal crash trends or anything like that?
Yeah, I haven't seen anybody do that. That would be an interesting thing to try to put those things side by side, because that is one of the things with some of these legislation changes and things like that. For instance, when they started mandating seatbelts in all vehicles. Well, the next year you're not going to have seatbelts in all vehicles. It takes a while for that to really trickle into the population of vehicles that are out there. And so you're not going to see an instant change in many of those kind of things when there is legislation, because it takes a while for it to really filter down. But that would be a fascinating thing to try to graph. After this legislation is passed, how long does it take for it to really have an impact? And that would be a great thing. I wish somebody would do that study, because that would be a really interesting thing to track and see.
Yeah, there's a lot of variables. It would be challenging, but that would be interesting to attempt. There was one comment in the chat saying, "Can we get more data regarding road diets?" I don't know if you want to go into a road diet discussion now, or kind of hold that until the end, because we can go off on a whole road diet tangent.
Yeah, let's save that to the end. We'll talk some more about road diets, and there's not a whole lot of information in the road safety fundamentals book about road diets. I mean, it's just a little bit of text in there. There are other things out there on road diets, but let's say that we'll come back and talk about that more at the end. That's excellent.
Okay, we'll table that one. I'll remind you.
Okay, yeah, please remind me when we get to the end. All right, so let's jump into Unit 2, talking about human behavior and road safety. A good friend of mine, Lap Hong, used to be the state traffic engineer. He always had he had a good friend that was a structural engineer, and he always said, "Hey, man, you structures guys have it easy, because you're always dealing with things that concrete and steel and stuff. It's consistent. As traffic engineers, we deal with people, with humans, and humans do all kinds of crazy, dumb stuff, and they're very inconsistent. Some people are paying attention, some people aren't paying attention. Some people are good drivers, some people are bad drivers. Some people have good vision, some people have terrible vision." And so, we have to deal with a lot more stuff than you structural folks. And so, yeah, certainly human behavior is one of the toughest things we have to deal with when we're talking about trying to make our roads safer. And so in Unit 2, what we hope to do is talk about the systems that drive human behavior, give examples of each, and then explain why it's important to consider the nature of human behavior when we talk about design or implementing systems or programs. All right, understanding human behavior. Human factors is defined as an applied scientific discipline that tries to enhance the relationship between devices and systems and the people who are meant to use them. As a discipline, human factors approaches system design with the user as the focal point. So it's, again, all about the user. And who is the user? Key principles: human factor or human behavior is guided by two different systems. Your behavior is guided by the intuitive system and the deliberative system. And we'll come back and talk about those in just a couple minutes. Humans are not exclusively logical, rational beings, and I mean, even each person. Some days we're more logical and rational than others. If we're upset at something, or we've had a really bad day, we may not think rationally, we may not act rationally. And if we're having a good day, maybe we're thinking rationally and logically, but other days we don't act so rational or logical. Human behavior is heavily influenced by the environments, by things that go on around us. That's certainly true. And humans do make mistakes. We all do make mistakes. Either we're not paying attention, we're not thinking about what we need to be thinking about, we're thinking about something else, or we're not thinking clearly about what we need to think about. We do make mistakes. All of us as humans do make mistakes from time to time. But one of the key things is the intuitive versus the deliberative side of things. Intuitive system, it's implicit. You don't really think about it. It's unconscious processing by which you make nearly instantaneous decisions and take a resulting action. Whereas the deliberative system is a conscious system wherein a person considers information using rational thought, logic, and reasoning in deciding on an action. So intuitive, you just know what to do and you do it. And deliberative, well, you got to think about it and process it. And so when you're deliberating about something in the deliberative system, it certainly takes a lot more time to think about it and time to respond, time to react, versus intuitive, you just know what you're going to do. And so this is something I've talked about, again, talking about design concepts and how we need to be thinking in terms of designing to make our roads safer. What do you think we should be doing? Should we be designing for intuitive type processes or deliberative type processes? And really the answer, I believe, is we need to be making our systems very intuitive, because we do have so many people that are not fully paying attention. They're on their phone texting, or they're doing something. And I mean, it's not just drivers, but pedestrians as well. And if people aren't paying full attention to what they're doing, are they going to deliberate or think about it? And so as we design pedestrian systems, as we design roadway systems for any user, we really should be focusing more and more on making it intuitive. I was involved in a intersection reconfiguration where we were trying to fix an intersection that was having safety problems, and it was down in the Florida Keys and had a lot of pedestrian use. It was very busy intersection, a lot of vehicle use, a lot of pedestrian, a lot of bicycle use. And they had recently rebuilt the signal, and the way they had set up the pedestrian use was not intuitive at all. And I said, we need to do something here to simplify this. It needs to be simple and intuitive for the users. And so we changed the way that the signal operated. It was a lot more complicated on the engineering side. So we had to do the engineering side a lot more complex, but to the user, it was much more simple. And that's, again, the way we need to think, not make it simple for the designer, but make it simple for the user. Because again, you have to think of who are the users. Well, the person crossing the road could be a 5-year-old child, or it could be a 95-year-old person with bad vision or suffering, suffering with dementia or something like that. So we have a wide variety of users, and some of those folks on the extremes still need to get safely across the road. And so it needs to be something that's intuitive and not require somebody really to read a sign and figure out how to use it. But, oh, okay, I push the button, and when the little white guy comes on, then I go. And it needs to be real simple and intuitive rather than something somebody has to read a user's manual on how to get across the road. It should be very simple and intuitive. And again, that's where we really need to be going with design if we're going to get anywhere close to Vision Zero. Some of the things we can do to change behavior, though. On the left, you'll see these bars that are put around a curve. And it's an interesting thing. It's in the MUTCD now. And what it's designed to do, it makes you feel like you're going faster. They're called optical speed bars. And as you go around the curve, by spacing the bars a little closer together, more and more close together as you get further into the curve, it makes you feel like you're going faster and faster. And so, again, intuitively, you think, gosh, I'm going too fast. I need to slow down, without really thinking, gosh, those things are getting closer and closer together. What are they trying to do? They're tricking me. So I guess again, they're called optical speed bars. You can read about them in the manual and uniform traffic control devices, and they have been shown to reduce speeds, vehicles going around curves. Now, we showed the picture on the right earlier, and again, if we have design elements that look like, gosh, I could go 50 miles an hour on this roadway, people are going to drive 50 miles an hour on the roadway. And if our design elements tend towards slower speeds, people will drive slower. I remember many years ago, West Palm Beach did a study on a roadway. It was originally posted at 35 miles an hour, and they did a speed study and did a study of the distribution of speeds on the roadway, and what was the 85th percentile speed, the mean speed, and that kind of stuff. So at 35 miles an hour, they did the study. Then they changed it. They didn't do anything to the roadway, just changed the speed limit sign to 45 miles an hour. They waited a couple of weeks, went out and did the speed study. It was the exact same distribution. The 85th percentile speed was the same, mean speed was the same. It was the exact same speed distribution. They went and then changed it to 25 miles an hour. So just changed the speed limit sign to 25 miles an hour. Wait a couple of weeks, go out and do the speed study. It was, again, the exact same distribution. And it really proved the point that the speed limit sign doesn't really impact people's behavior. People are going to drive the speed that they feel is safe and comfortable. I mean, unless you have very aggressive enforcement out there, people are going to drive whatever speed they feel is safe and comfortable. And so just changing the speed limit sign had absolutely no impact on what people were actually driving there.
Hey, Larry, there's a question about the speed bars. Are there
Yes.
any studies indicating their effectiveness that you're aware of? Any before and afters, or?
Yes, there are some studies on it, and in the manual, in the Road Safety Fundamentals manual on page 2-4 is a discussion of the optical speed bars, and it references FHWA publication Countermeasures for Reducing Speeds, a desktop reference of potential effectiveness. And so again, yeah, that is one of the great things about this document that we're talking about here, the Road Safety Fundamentals book. It has information on these things, and it does cross-reference to other studies. So again, that's on page 2-4 of the manual if you want to check that out. And it again references where you can download that particular desktop reference of potential effectiveness, and it'll document the studies of that. Great question. And again, like I said, we should design for the user, not the designer. Like I said in the Key West example I mentioned, we should be willing to do a lot more hard work on our end in the design and construction so that it's intuitive to the user. So we should design roads not for the way we would like them to behave, but the way in which they're going to behave. And we should, again, be thinking, make it intuitive for that user so they know what to do. And, if we do right design, it encourages right behavior. In general, people don't just do what they're told to do, whether it's a sign, a law, or another person. They integrate all this different information from different parts of their environment along with their experience as they determine what they should do in a given situation. And so we should design, again, for intuitive type approach from all the roadway users so that they don't have to think about what to do. Again, don't have to read some sign that explains to them what they're expected to do, but they just approach the intersection. They know what the right thing to do is and they do it. And it is safe and effective and works for them. And so again, right design encourages right behavior. All right, next chapter talks about changing human behavior. How do you change human behavior? Well, if you change the environment, you change things around people so that they make different choices. That's certainly one way to do it. Change the environment. You can educate them. You can provide safety messages and raise awareness, or you can do the brute force way, which is enforcement. So, heavy police presence will get people to slow down on a roadway. I mean, like I said, welcome to Waldo. If you're familiar with Waldo in North Florida, they aggressively enforce the speed limit there. And people would typically drive a lot faster through Waldo, except for the fact they are known as a speed trap, if you will. And so when you see the sign, welcome to Waldo, you hit the brake and you slow down because they aggressively enforce the speeds there. But that is really the brute force way, and something a lot of agencies really aren't willing to do, because people then complain, you should be out solving this crime or that crime and not just ticketing people. But I don't know, there's a lot of good research that actually supports it does make your community safer if the agencies are aggressively enforcing speeding. And we can talk about that later if someone has a need to or want to. All right. Some of the things that do influence our decision making, what's convenient for us, previous experience in a similar environment. Sometimes we're under time pressure. We're in a hurry to get something done. If we've had education and know how to do things, our emotional state of the time certainly does impact things. I was driving in Tampa a few weeks ago, and man, this guy was just full of road rage, and I got out of his way as fast as I could. I wanted him to go around me, and he was in the lane next to me, and signal turned green, and he started honking his horn at the person in front of him, and I was just shaking my head. Man, what is wrong with this dude? And then he rolled down his window, started yelling at me. I thought, he was going to jump out of his truck and try to start something with me. But I mean, his emotions were out of control, and I didn't want any part of that. Just, hey, just go on. I'm out of your way. Go, man. Get out of the way. But that certainly does influence how people respond and how people operate in the road system. And certainly, I think that dude needed to definitely calm down some, because he was going to, hurt somebody or cause a crash. But some of the other things that influence how we respond, cultural norms, what's common in the culture. And boy, that's certainly true. I live in a very rural environment. The traffic's usually really low, and people around here, they drive, they're a lot slower to take off when the signal turns green. People are a lot more calm. But you go into a real dense urban situation. I do a lot of work down in Miami, for instance, and man, you get down there and it is a whole different world. And so some of the cultural norms certainly influence the way people respond in our roadways. Religious beliefs, or social pressure, other habits, finances, all these things can influence how people respond to the stimuli around them. Well, let's look at an example here. Mid-block pedestrian crossings at a bus stop location. What are the factors that influence this behavior? So we see this all over the place. The bus stop is mid-block, and you've got signals up the road and down the road. Why do people cross at the bus stop? And so, well, certainly it's more convenient to cross right there mid-block rather than walk up to the signal, cross at the signal, then walk back towards the shopping center. If I'm going from the bus stop to the shopping center, and it's a whole lot more convenient to just cross there. If I've had previous experience and I know, well, I can make it safely across here, then certainly you'll cross there. And if you're in a hurry, man, I don't want to wait all day. I need to get to the shopping center, get what I need, and get back over here, catch the next bus. Well, certainly, those kind of things would impact your choice. Am I going to cross mid-block or am I going to walk up to the signal? I think one of the other things, and I heard somebody bring this up a few years back, and it really stuck with me. I think one of the other things that really impacts particularly mid-block bus crossings is that's what we're taught to do. You think about when you were a kid in school, you get off the school bus, that little stop arm goes out on the school bus and you cross right there at the bus. And you're taught that, for all your developmental years. So then you become an adult, you get on not a school bus, but a transit system bus. What do? You get off the bus and, well, you cross right there because that's what you're used to. You cross, right where the bus lets you out. And again, that's something I see over and over as I have done road safety audits and other things all over the place. People get off the bus and that's where they cross. I mean, I was at an intersection in Orlando and I remember, person got off the bus and that's where they crossed. The signalized intersection with the signalized crosswalk was 25 feet away. It wasn't 200 feet away. It wasn't 2,000 feet away. It was 25 feet away. They didn't cross there. They crossed right where they got off the bus. And again, I really think a lot of it is that's what we're trained to do since we were kids. We get off the bus and that's where we cross the road. And so again, that's the kind of things that do influence the human behavior there. And so how do we change that? That's a tough question, isn't it? And something we continue to struggle with. Again, like I said, right design encourages right behavior. And like we said, humans are not exclusively logical, rational beings. People generally don't just simply do what we're told. Changing behavior requires understanding all these influencing factors. And if you can't change the person, and usually you can't, change the world around them so that they will follow. So you have to change the environmental clues around them. Because again, right design encourages right behavior. And you can see they've got the temporary barriers there. If they just had the one opening where the crosswalk is, that's where people would cross. But again, the extra opening there. And so people are going to cross wherever they feel like they can cross. And often it may not be where you want them to cross. All right, that was quickly through Unit 2. Any questions there on what we covered there?
There was a lot of interest on the optical speed bars. Some follow-up questions that were coming up. Can they be used on tangent sections as well as curves? And are there studies kind of showing their effectiveness on curves versus tangent sections?
I'm really not sure that, like I said, it is something, there is some information in the MUTCD about when to use it, where to use it. It typically is applied, I've only seen it applied on curved sections where you're really trying to slow people down going into a curve because there's a history of people driving too fast and sliding out of the curve. And so it's something, again, that's been implemented as a particular countermeasure in curves. I really don't know if doing it in tangent sections has really been studied. I could see certainly if you were changing speed limits, and so going from like a 55-mile-an-hour speed limit down to a 45, it might be something useful there to get you to, oh gosh, I really need to slow down going into the reduced speed section. But yeah, I'm not aware of any studies particularly on that. Like I said, the typical application of it has been in curved sections. And like I said, if you look in that, let me see if I can find it again. If you have the road safety fundamentals document, download that on page 2-4. It'll give you that FHWA document that does have the studies, and I would refer you to that. You could probably learn a lot more from there. But like I said, I believe most of the applications where it's been tried have been on curved sections, but that's an excellent question as well. Yeah, I'm not aware of any.
The only other place I can think of would be like in places where you would put the longitudinal rumble strips, like approaching a T intersection or a rural intersection.
Hmm.
where you're wanting people to slow down on approach, I would maybe consider it there.
Yeah, that'd be a really good application. And I'm not aware of any in any applications in Florida where it has been tried, uh, but someone else may know. I don't know. But again, the whole thought behind it is, you know, creating a visual, uh, basic, optical illusion kind of thing, so it forces you to think I'm going faster than I'm really going.
Yeah, no,
So.
the theme parks do that a lot. Like when you're riding in Space Mountain, there's a section where there's a dark tunnel. You're
Hmm.
going fairly slowly, and there's a fan blowing down the tunnel, and there's lights that are, making it seem like you're going a lot faster. So I think safety engineers are learning from the Imagineers and making it safer on the roads for us.
Yep, exactly. And I mean, that's a good thing to try, because again, what you want to do is change the environment around you so you do the intuitive thing, which is slow down. And so that, again, it would be interesting to see some other applications of it, like the one you mentioned. That's a great application where you have the rumble strips and you want to get people to stop coming up to those rural intersections. That's a really good application of that. So very good.
I had a I had a savvy engineer ask me one time if anybody's ever considered with regarding speed management, and it's kind of related um, to this optical approach is changing the spacing of the 1030 skips on the roadway, so that instead of being uniform, so that it's 1030,
Hmm.
they actually change with the speed limit, so that rather than so that the lines and the RPMs and everything along the roadway approach the driver at a certain cadence.
Yeah.
So if you're driving on a slower speed road, the lines are closer together and you see them at that same cadence because you're traveling the speed limit. If you're traveling on a faster road, then they're farther apart, so they hit the driver at the same speed. So you'd be able to set the speed limit by kind of counting as those lines are coming at you.
That would be a great research project. Yes, I'm not aware of anybody that's tried anything like that. Pretty much the 1030 skip is pretty standard, and regardless of the speed of the road. But I really think that would be potentially something helpful. So that's a really great thing that, again, I wish somebody would give that a try. And, you know, I guess probably the thing we could do, try it in simulator environments first and see if if there was a real potential for something there, and then go from the simulator environment to some roadway environments and really test it and see what the impact is on people. But that's a really good, interesting suggestion. That's real good. And again, that really plays into change the environment, so people are perceiving, even though they're not consciously thinking about it, they're perceiving, oh gosh, those lines are going by too fast, I need to slow down. And that is a real good application of that thought process. So that's something to really think about. Excellent research project. So if there anybody out there, from the universities, write that up. That's a real good suggestion. So
That's two great research projects we've thrown out there so far. So there's
good.
great value in these LATSA webinars, right?
Exactly. So any students out there, you want something to really study for your PhD, that's it, man. Some really good applications there for sure. All right, now unit
Uh,
3. No, I'm sorry, go ahead.
No, I was going to say there was back when you were talking about roundabouts, there was a question if we're aware of fatal crashes occurring at roundabouts, or if their effectiveness in reducing the severity of crashes, kind of holds true.
Well, I'm sure certainly there has been fatalities at roundabouts, but you know, they are very infrequent. Most of the crashes you have at roundabouts are same direction side swipes or rear end collisions, which tend to be less severe. But sometimes when you get people doing all kinds of dumb, crazy things, entering the roundabout way too fast and driving over the center island and that kind of stuff, you know, I'm sure there have been fatalities in roundabouts, but they are rare. And so certainly a roundabout is a good device, but it doesn't always uh, fit every location. And again, it requires all the users to be that fifth E I talked about, everyone else doing the right thing. So, all right, well, let's
Depends
look real quick.
depends on
I'm
whether or not
sorry.
they have a fountain in the middle of them, right?
Exactly. Yes. Yes.
With the one last thing before we move on to the next section, with regards to the optical speed bars, there was a comment in the chat that the city of Fort Lauderdale has experimented with them. There are some on Andrews Avenue south of Cypress. So
Oh,
check
okay.
out Andrews Avenue south of Cypress and Google Street View. Maybe it's there. And if you have any other questions, maybe reach out to the city of Fort Lauderdale.
Oh, okay. That's good to know. Okay. All right. Excellent. It's good to have a audience like we have here that are all over the state and familiar with different applications like that. That's really good. All right, well, the next unit, we're going to look at measuring safety, talk about the importance of safety data, types of safety data, and how to improve the quality of the safety data. And so, again, our learning objectives describe why measuring safety is important, identify the different types of available data, understand the challenges, the accuracy of the data, and select data for different road safety objectives. What's the appropriate data to get? And so we'll begin by the importance of safety data. And I mentioned this earlier, and again, if you get nothing else, I hope you all walk away from this webinar understanding the difference between nominal safety and substantive safety. And nominal safety refers to, have we met the design criteria? Have we met the design standards? And if you've met the design standards, many people walk away from that thinking, okay, well, it's safe. We check the box, that we've met nominal safety. But real substantive safety is the substance of safety, and you're measuring real safety performance, real crash data, and that's what substantive safety is. It's, again, the real substance of safety. And again, we need to understand the difference there. And just because it's nominally safe, just because it meets the design standards, does not necessarily mean that we've done the best we can there. And so we need to be thinking again in terms of substantive safety, not just nominal safety. All right. When it comes to safety data, this matrix you see on the screen, it's an interesting thing to think about. If you really have low quality data, our worst case scenario here is we have low quality data and we really don't do much analysis with it. This is the worst case. If you have poor data and you really don't know what you've got and don't know how to analyze it and get anything useful out of it, you're going to make bad decisions. And so your agency may be better off relying just on judgment. You're really not spending your money effectively if you don't have good data and you're not analyzing it well. The easiest thing to do is, step up your analytics, your analysis of the data, because sometimes getting good data takes time and money. But again, studying a book like this book can help you do a better analysis. So even if you have low quality data, if you do high quality analysis, you can recognize, well, the limitations of the data that you have, and you can still get some useful results that'll help you move in the right direction. But again, the thing you want to work on there is improving the data quality so you can make better decisions. Again, if you have real good data, but you don't really analyze it, that's in the upper right-hand corner here, the missed opportunity. So you have really good data, but you really don't know what to do with it. You're missing the opportunity there because you're not getting the maximum you can from your data. You've collected all this data, but you're not really learning all that you can from the data to help you make better decisions. And certainly the best case scenario, you've got real good data and you apply real good analysis to it. And this is what we're really after. In all the work we do, we try to make data-driven decisions to analyze the data, figure out what's really going on, and apply the best countermeasures to it, doing analysis to really figure out what's going to work, what's going to really reduce crashes, make our roadways better based on the data. And that's a data-driven analysis, and will give you the best type of response to the crashes that you're experiencing there. So the next chapter talks about the types of safety data. And some of the critical pieces of data are the crash records. That's where you really learn the most, is reviewing the crash records. What are the traffic volumes on the roadway and some of the characteristics of the roadway? And certainly the crash records The Florida crash report has lots and lots of data fields on it, loads and loads of data fields. This is just a small portion of the Florida traffic crash report. But as you read the traffic crash report, there's lots and lots of data there, and it really helps you understand what went on, what may have contributed to the crash, what are the specific things related to that crash that you need to be aware of. And again, the crash records, having good crash reports just really helps you figure out what's going on. What are the things I need to be looking for? What are the things that may have influenced this crash? And there's all kinds of things described on the crash report. What is the lighting conditions? Was it light or dark? Do we have street lighting? Is there, is it a situation where you might have glare? Then the weather conditions, is the road wet or is the road dry? Is it some other windy blowing condition or something like that? And so all these different things can impact what you would do, what the correct countermeasure is at a particular location. What's the roadway surface condition? Were there heavy vehicles involved? Were there school buses involved? And all these different things help you identify what are the things that may have contributed to the crash, so that I can come up with what are the solutions I may want to try to reduce this type of crash. Some of the supplemental data, you may want to get out and watch the intersection. Are there a lot of conflicts, people slamming on the brakes, moving out of their lane to avoid crashes? Are there things you see like that that are near misses? And if there's a lot of near misses, well, okay, there's something that's impacting people's ability to see and respond, and I need to take that into account. What is the severity of the crashes we're experiencing there? Are there adequate EMS capabilities in the area? Is the crash caused by, just we've got a bunch of bad drivers out there? Looking at vehicle registration data, other things like citations, naturalistic impacts. We can try things in a driving simulator and look at behavioral observations. One of the least effective things, I think, at least in my experience, is often getting public opinions, because, public opinion is always all over the place, and, oh, this is the worst intersection in the world, and you get out there and it looks like any other intersection. So sometimes public opinion polls can give you useful information, but often it's biased and unreliable. So you really, I think, want to get out there, watch the intersection in operation, and really see how people are responding to what's there. In the crash data, again, looking at the crash form, you'll see a description of all the crash things that may have influenced the crash. The data collection process is something the police officers are trained in what data to collect and how to collect it, and it's a very elaborate training that they have to go through when the responding officers are putting that data into the form. It's a very robust training they go through in order to know how to fill out that form. We're going to talk about the common data elements, the MMUCCU, and that's something, again, if you're going to be taking the RSP exam, you need to know what that is, and we'll talk about that in a few minutes. Whenever you have crash data, what are the sources of data and who keeps the data? And is the data safe and secure, and is it reliable? We'll be talking about the transportation safety applications and coordination of the data with other agencies. And we'll talk some about the data challenges and the gaps, and because that's always an issue. What gaps do I have? Where am I missing data? What's the data that I don't have that would help me better understand the crashes? Traffic volume data, typically, we have AADTs, the annual average daily traffic for most of the roadways in Florida, at least the state roads. The DOT tries to maintain a database of that information. The AADT is the annual average daily traffic. And basically what that is, you take the total number of vehicles that go across that section of roadway over the course of a year and divide it by 365. Of course, for 2020, you would divide it by 366 because we have a leap year, but I mean, it just assumes, uniform number of vehicles per day throughout the year. The difference between AADT and ADT is ADT is typically talking about a smaller time frame, a month or a week or something like that. And particularly if you're in an area with a lot of tourist or snowbird type influence, that's the difference between peak season and non-peak season. Done a lot of work on the west coast of Florida and certainly Fort Myers and Naples and some of those towns. Huge impact in season versus out of season. And so it's 20 or 30% more traffic in season versus out of season. And the residents certainly know that. And it certainly is something you need to be thinking about when you're doing crash analysis or safety analysis. Did this occur in season or out of season? Because it certainly impacts how the roadway is operating when you have 20 or 30% shift in traffic. For intersections, we don't think so much just in terms of ADT, but total entering vehicles, or it's often MEV, million entering vehicles per year at an intersection. And that's typically what's used as the volume data for an intersection. At the intersection, you would also want turning movement counts, how many are turning left versus how many are turning right, how many going through from all the different approaches. And that certainly does, again, impact your crash history. How many vehicle miles traveled? Again, that's related to your AADT. Ped and bike counts is something we don't have a lot of data typically, pedestrian or bicycle exposure. Nowadays, with the more modern video-based traffic data collection equipment, we're starting to actually be able to collect more bicycle and pedestrian counts. It has always been one of the real weaknesses we've had. Typically, if you look historically, bicycle and pedestrian crashes are in terms of, per 10,000 residents or per 100,000 residents or something like that in an area versus, how many bikes cross the road or how many pedestrians cross the road, because it's always difficult to collect that. But again, now with some of the more modern video data collection equipment, we can actually start to get better estimates of pedestrian and bicycle counts. And certainly classification counts, having percent trucks and buses and those kind of things, are certainly important to our crash history as well. So this is the traffic volume data that's useful and helpful when trying to analyze your crash data. We also want the roadway characteristics data. How many lanes are out there? What's the pavement type? The width of the roadway, width of the shoulders. Are there ped and bike facilities? What's the slope of the roadsides? What type of traffic control do we have out there? What are the posted speeds? All these things and a whole lot more are the roadway elements we really need to analyze the crash data. And really, the types of safety data we need, you can see volume data, we need all the traffic volume data, crash data, and the road data. So we need the crash reports, how many vehicles or pedestrians or bicycles or trucks or whatever is out there, volume data, and what does the roadway look like? So all of these three realms are important data to really analyze if we're going to be trying to figure out what's going on and understand the crash experience that we're seeing there. All right, Chapter 9 talks about improving safety data quality. And to have good safety data, you need timely data. That means it's fairly current. It was something for many, many years. The crash data we got was not timely at all. It would take 3 or 4 years before we got the crash data. And, by then you've already done something to the roadway or, something has happened and changed things. And so you really need good timely data, as current as you can possibly get it. It needs to be accurate. It needs to be complete. That's one of the things with the Florida crash form. I forgot how many data fields are on it, but there's lots and lots. There's hundreds. And, the officers get tired of filling all that stuff out. And so you need all those things filled, though. It's all useful information on that form. And so the crash data needs to be timely, accurate, complete. Uniformity, and I'll come back and talk about uniformity in a while, but we need to be talking the same thing all across the state and all across the country. So we have good uniform data. We need to have it integrated into other databases, and it needs to be accessible so people can get this data, use it, and make good choices. I mentioned this before, the MMUCC, the Model Minimum Uniform Crash Criteria, and this is all about having uniform crash data. And just like if you're familiar with the manual on uniform traffic control devices, if you're familiar with the history of that, before there was a MUTCD, different states had different signs and different colors of signs and different designs of signs. I mean, it used to be there, many of the stop signs you saw were yellow with black stop text on it. And it wasn't until the MUTCD that they said, hey, let's all do the white letters on red background for a stop sign. And again, the thought is as you drive from state to state, you should see the same kind of thing so that you know how to respond. And so uniform traffic control devices, gives a better design. People know what to do as they go from place to place. And same thing really with the crash data. The thought behind this MMUCC is we need to have consistent crash data, because if we're comparing how one roadway operates and its safety performance with another roadway, we need to be comparing apples and oranges. We need not to be having apples and oranges. We need to have apples versus apples. And this is especially important for things like highway safety manual applications, because the predictive methods on the highway safety manual are based on studies in other states, typically, a few studies all over the place. And if in one state a fatality is considered if somebody dies within 30 days after the crash, in a different state, it's 90 days after a crash. Someone dies 90 days after the crash, that's considered a roadway fatality. That's, again, comparing apples and oranges. If one state it's 30, another state it's 90. And so we need to have the same criteria for analyzing crash data all across the country. And it creates, if we're able to do that, uniform, accurate, reliable crash data so that we can, again, make better data-driven decisions. And so that's the whole thought process behind this MMUCC, is having better quality safety data, uniform safety data all across the whole country. Now for the roadway side, MIRE is the model inventory of roadway elements is MIRE, the model inventory of roadway elements. And it's the same thing, that we want to have the same type of data, same type of information about the roadway side of things that we analyze as we're analyzing the crash data. So we have good crash data that's hopefully uniform and consistent. MIRE is all about having the same type of uniform roadway element data. And roadway segment data, the alignment of the roadway, are there horizontal curves, vertical curves, or is it an at-grade intersection, so forth. And so again, MIRE is basically the same thing as what we saw with the MMUCC, uniform data, in this case describing the roadway elements. That's what MIRE is all about. All right, that was Unit 3 real quick. Any questions, Anthony, on Unit 3?
There's a comment in the chat saying that people have had different experiences. There's more than one comment in there saying that they've looked at different locations and different municipalities, and the inconsistency in the crash data is frustrating. With regards to like the conditions of the roadway and things of that nature. So I mean the efforts to standardize that are definitely welcome.
Yeah, absolutely. And different cities and different municipalities had different standards and different quality of crash data. And that is the real emphasis behind some of these things, the MMUCC and the MIRE, is to standardize these things so we are all talking from the same frame of reference. So,
is there a list of compliant states that that these guys develop? Here's the minimum number of required fields for a crash report form, and then kind of states can add to it, or like how does that work?
I believe they are tracking some of that stuff in the and again in the roadway safety fundamentals document. It talks about Meyer and the MMUCC in some detail, and it points you to, I think there are some websites that talk about states that have fully implemented it and where the different states are in implementing it. So there's, again, I'd point you to the text. The book has a whole lot more information and points you to websites and other reports that could really answer that question better than I can.
And it's from a crash data analysis system, analysis level. Having a uniform crash report form for the entire country would be very beneficial. I mean,
Absolutely.
you develop a system that works in one location and it works everywhere.
Absolutely, absolutely. That would be such a benefit to really doing better safety analysis. And again, it's what we really need if we're going to make any sense out of the data that is going to be feeding future versions of the highway safety manual. Because if you're measuring things differently in one state versus another, and you throw that into the safety performance functions, your results really aren't right, are they? And so it's important that we get to a more uniform crash data system across the country that will help us have better data-driven decisions, I think. All right, let's move on. Unit 4, solving safety problems. And again, what we hope to do here, 3 major components of road safety management. We'll talk about that, defining the process, conducting site level and system level safety management, and use safety data to identify safety issues and develop strategies. All right, so the 3 major components of road safety management are identify the safety problems, devising potential strategies, and then selecting and implementing those strategies. So here's some examples of various categories, safety analysis, some lists of the data that you would need in order to conduct them. If the question you're trying to answer is how many fatalities, serious injuries are occurring in my area, well, you need to know how many crashes, how many fatalities, how many serious injuries. You need that kind of crash data and injury data. How does this compare to other areas of my state? So you need, roadway data, your agency geographic boundary information. Those are the kind of data things you would need in order to answer those safety questions. What types of road users are involved in crashes? When are the crashes occurring? What are the major contributing factors to crashes? And the data needs that you have to try to answer those. What's the severity, crash severity? The crash incidence data, time of day, is it raining or is it dry, night, day, that kind of stuff. What type of crashes are we having, and what are the contributing factors that might be and again, that's the kind of stuff that's on the crash report. The officer has to fill that out, some of the contributing factors based on what he observes and the witness statements that he gets there. What locations show the most potential for safety improvements? And again, if you're going to try to answer that question, you need to know crash severity, location, the characteristics of the roadside environment, what's the traffic volumes, and it's helpful if you have good calibrated safety performance functions, so you can do predictive analysis. If your question is, what are the common characteristics of the locations with crashes? That's a really excellent question to try to pursue. What are the common characteristics that I might see at locations that are experiencing crashes? Well, you need to know what are the crash locations. You need the roadway characteristic information, traffic volume data, and then, okay, you can start to assess what are some things that might be contributing to crashes at those types of locations. And so then what are the countermeasures to address those types of crashes, the characteristics, and how should we prioritize the implementation of those things? And so this is part of the road safety management process. All right, that's a real basic, quick view of the process. And then the next chapter goes into site level safety management. How do we apply the answers to those questions, if you will, in choosing what to do? And so what you see here, these are the steps to a site level safety management. And A lot of this comes pretty much out of the highway safety manual, if you're familiar with the highway safety manual. And so we begin with network screening, diagnosis, selection of countermeasures, the economic appraisal, where you do the benefit cost calculations and those type of things. Project prioritization, where you choose what projects go first, which ones can I fund, and that kind of stuff. And then you always follow that up with how effective was I? You measure you evaluate the effectiveness of the change that you made, and the process starts over again. It's an ongoing process, and that's the only way, again, we're going to ever get close to the goal of Vision Zero, is we make these improvements. Hopefully it reduces crashes, but there's still crashes out there. We've got to then start over again. Network screen, diagnosis, countermeasure selection, economic appraisal, project prioritization, and then evaluate where you are and are you headed in the right direction, and keep going with new countermeasures, measuring, diagnosing, prioritizing, etc. And so again, we talked about the previous chapter, talked quickly about identify safety problems, develop the safety solutions, then select and implement them. And the 6 steps that we just showed, you can see how that fits into that 3-step process there. So we start with the network screening and the diagnosis. That helps you identify what are the problems we're going to try to address. Countermeasure selection and the economic appraisal helps you develop those safety solutions you want to implement. Then step 5 and step 6, where you select and implement the strategies, you prioritize what things are going to be done first, what you can afford to do, and then again you evaluate and see how well it did what you intended, how well it did what you wanted to accomplish there. All right, this is a table, and this is if you're following along in the book, which probably nobody is, but on page 409 of the text is where this is. And it really walks you through for the different performance measures. Does this account for traffic volume? Does it account for regression to the mean? That's RTM, regression to the mean bias, and I'll explain that in just a couple slides. And does it account for crash severity? If your performance measure is just the average crash frequency, how many crashes are we getting there every year? That doesn't really account for traffic volume, doesn't really account for regression to the mean bias, and doesn't really account for crash severity if all you're looking at is number of crashes. But as you look at other performance measures, the crash rate certainly does account for traffic volume, certainly does not account for regression to the mean bias, does not explicitly account for crash severity. Some of the other things you can do, the EPDO, equivalent property damage only crash frequency, basically what you do there for the EPDO, you say that each fatality is worth a certain number of property damage only crashes. And so, one fatality may be worth, hundreds of or thousands of property damage only crashes. An injury may be worth, a few hundred property damage only crashes. And so what you're then doing is weighing those more severe crashes more heavily. And that certainly does account for crash severity, but it doesn't account for regression to the mean or really take into account traffic volume. So you can see for all the different types of performance measures, I don't want to spend too much time on this, but for different performance measures, you might be looking at, does it account for the traffic volume? Does it account for regression to the mean? And does it account for the crash severity? And here's a few more here. The number 9, the probability of specific crash types exceeding some threshold proportion. Again, you can see it doesn't account for traffic volume, not affected by regression to the mean bias typically, and not explicitly accounting for crash severity. And so you can see there's a lot of choices you can make as the crash analyst. What is my performance measure going to be? And does it account for the traffic volume? Does it account for regression to the mean bias? And does it account for crash severity? And so again, that's just a helpful table there to really help you with network screening and your performance measures. The document shows a couple of SPFs graphically here for, in this case, multi-vehicle crashes on a rural 4-lane freeways. And you can see the SPF would be the green line, and all the data points out here are scattered all over the place, but they're all analyzed into a single SPF, which again is the green line running through there. But you can see there is a lot of variation in the data, and that is something that we must understand. We're taking data from a variety of different states that have different roadway design experiences and different weather experiences and other things, and that's how we get the safety performance functions that we use in the highway safety manual analysis. And it is important that we as practitioners be aware of how much variation there is in the data. Here's a similar type figure for single vehicle crashes on rural 4-lane freeways. And again, there's a lot of spread in the data, but the SPF gives you, if you don't have anything better, the best available number to predict the crash performance for that type of roadway. And again, the way that you use these and analyze those, the SPF gives you a number. Based on the AADT, you can estimate or get a predicted crash frequency. If you also have good crash data, the little triangle at the top is the observed number of crashes. And so your observed number of crashes in this case is up above the SPF, the safety performance function value. And so using what's called the empirical Bayes analysis, you get the one in the center, the diamond-shaped data point, and that's what's called the expected number of crashes. And the expected number is the blending of what's predicted by the safety performance function based on other locations that have been studied and your observed number, and it blends those together to come up with what's called the expected number of crashes. And again, this is site specific. You're looking at your site level safety management. And again, you're blending my historical data that I've observed with historical data from other locations that are hopefully similar from the safety performance function. And I'm getting what should be what's called the expected number. And this all has to do with what you'll hear people talk about, the regression to the mean. And using the empirical Bayes method, hopefully we take care of regression to the mean. What regression to the mean is the crash data historically is all over the place. And it's very random. And if you do nothing to a roadway, you're doing absolutely no treatments, it's going to vary year to year like what you see on the chart here. And so year to year, you're going to have some years that are high, some years that are low, and it's going to vary all over the place. And the line you see across the screen where it says long-term average, so that may be a 15 or 20-year average. Well, and so you can see there's a lot of data above it, a lot of data below the line, but that's your long-term average. If you look more short-term, in a 4 or 5 year horizon, you got short-term averages, that some years are low, some years are high, but it fluctuates all over the place. Well, using the empirical Bayes method, again, what you're trying to do is come up with something that should be closer to the long-term average, because you're blending your data, which hopefully you've got a short-term average, and averages from other locations into something that hopefully is close to the long-term average. And again, the regression to the mean, again, what it really is talking about is the data is highly variable. It's going to vary all over the place, but one year it's going to be real high and you think, oh gosh, things are terrible, when nothing's really changed. You just had a low year the year before or something like that. And the next year may be real low and you think, gosh, we did something really great, when you really didn't do anything. And again, it's just due to the natural fluctuations. I remember years ago, I looked at some fatality data on this rural county in District 2. And they typically had 1 or 2 fatalities per year. And then all of a sudden, one year it jumped to where there were 9 fatalities. And I sat and talked with the district safety engineer and said, whoa, what happened here? Well, they had a concrete truck run into a school bus. And there were 7 fatalities at that one crash. And so it really wasn't a huge difference in the number of fatal crashes, but the number of fatalities went way up because of that one crash. Concrete truck runs into a school bus and a whole bunch of kids died. And so, again, that's the kind of thing, regression to the mean is all about eliminating those kind of bizarre fluctuations that just unfortunately naturally occur. All right, well, a big part of trying to figure out what we're going to do to solve safety problems is getting out in the field and analyzing it. And one of the best tools, I think, to do that is a road safety audit. And a road safety audit is an independent multidisciplinary team. You're looking at all the potential road users, not just vehicles. And again, you're thinking in terms of human factors, looking for the road user capabilities, limitations. If you follow the formal RSA process, then it's going to generate a formal report, and whoever the road owner is generates a formal response. And the road safety audit is a great tool if you use it properly. A traditional safety review is a lot different. The safety review team with only safety or design experience goes out and collects some data. They concentrate typically only on motor vehicles. Again, often doesn't consider human factors. A lot of times that traditional safety review doesn't generate a formal report, maybe just a work order, hey, fix this, go out and repaint the markings or whatever. And there's often not a general formal response. The RSA is a great tool. Again, if you follow the process and do it right, it will really do a lot to improve the safety of any roadway that is properly analyzed like that. Now, this is something in the chapter here. This is if you plan on taking the RSP exam, I'd recommend you study the Haddon matrix. I had never heard of the Haddon matrix until I opened this up when I was studying for the RSP exam. And what the Haddon matrix is all about is it's looking for some of the contributing factors to a crash. And it talks about some things pre-crash, during the crash, and after the crash. What are the human type contributing factors, the vehicle contributing factors, the environment contributing factors, or perhaps socioeconomic contributing factors that may have contributed to the crash. And so, for instance, if a person has poor vision or poor reaction time, or they've been drinking, or they're speeding, they're driving aggressively, those kind of things, that's something all human related pre-crash. And so if all those kind of things are going on, or some of those things are going on, then that certainly does contribute to a crash occurring. And likewise, on the vehicle side, if your brakes aren't working right, if you're missing lights, or other things like that, that could certainly contribute to a crash or the potential for a crash. That's certainly a pre-crash type contributing factor. And likewise, all the other different things listed here in the matrix, pre-crash, crash, and post-crash are contributing factors that could contribute, obviously, to the incidence of a crash. And so again, I had never heard of the Haddon matrix until I was reading this in preparation for the RSP exam, but if you are going to be taking RSP exam, you probably do want to be familiar with the Haddon matrix. All right, if you've done any highway safety manual type of studies or anything related to the highway safety manual, you've probably heard of crash modification factors. They are multiplicative factors used to compute the expected number of crashes after implementing a given countermeasure. And so if your CMF is less than 1, you should be expecting fewer crashes. If your CMF is greater than 1, you're expecting more crashes. But if your CMF is 1.0, then you've done nothing. You'll have the same number of crashes in the future as you did before. The CMF Clearinghouse, if you've not ever been to the CMF Clearinghouse website, tons and tons of CMFs crash modification factors there. Be very careful when using them. I did a webinar a couple years back on the use and misuse of CMFs. I would refer you to that. It's on the LATSA website. You can access that webinar. And again, you just have to be careful when using those CMFs. Make sure you're using them appropriately and properly. All right. Now, economic appraisal of these safety things. Net present value is one of the more common ways to analyze them now, but certainly to do that, we need to compute benefit cost ratios and analyze, is this a positive improvement we're making? Does it have a good benefit cost ratio? And typically, if we're going to get federal funding, we want at least a BC of 2.0, but certainly anything 1.0 is good, but we like to have an extra margin of safety just in case the cost side is underestimated. And then we want to look at cost effectiveness index, and that's discussed in there. How effective was this in really reducing crashes? And so essentially, what's the cost per crash reduced? And were we effective in using the money to save lives and reduce injuries? And the safety effectiveness evaluation, again, we want to make sure that what we're doing makes sense. And so there's a couple different experimental ways to analyze projects and make sure, again, that we're using money wisely, that we're getting good data, and that we're really reducing the crashes that we want to reduce, and we're effectively using the safety dollars. The two broad categories, like I said, experimental or observational type of evaluations. And again, we just want to make sure that we're using the money wisely and have good data that also feeds future crash modification factors, that helps us to grow and learn more as we continue to improve our safety program. All right, on the system level now, going into chapter 12, it's the same things: identifying safety problems, developing strategies, and selecting and implementing these strategies. Now, one of the other important things we want to make sure everyone understands here, the difference between system-wide and systemic. System-wide, or sometimes called systematic, you treat all the safety issues across an entire system just uniformly. We're going to do this at every single intersection. And that's a system-wide approach. The systemic approach is you pick out intersections that have certain criteria where you really think a certain countermeasure is most needed, where it's going to be most effective. And so that's the difference really between system-wide and systemic. System-wide, we just apply it blindly everywhere. And systemic, we're going to apply it in certain places where we think it's going to be the right thing to do at that location. And so it's important that you understand that difference between system-wide and systemic. That's a very important differentiator in the Highway Safety Manual and in the Road Safety Fundamentals text here. When you're selecting the strategies you want to implement, you certainly want to be looking at what is my expected effectiveness. Is the public going to like this? Anthony mentioned in rural areas having rumble strips on the approach to the stop sign. You don't do that in urban areas because the public doesn't like it, because it makes a lot of noise. And so you have to have good public acceptance of the countermeasures you're going to implement. Who are the stakeholders? Who are the partners? Is it cost effective and cost efficient to do this? And how much time is it going to take to implement these things? And so these are some of the considerations you need to be thinking about when you're thinking about your safety strategies. The next chapter, who does what? When we're talking about implementing our road safety effort, who does what? For different areas, you can see the chart here lists, who implements things from the federal side, the state side, or the local side, who are typically the responsible offices for road design or the environment. At the federal level, that's federal highways, the state DOTs, and at the local level, city public works or county public works or whatever. And so those are the people typically involved in those things. And you can see here for all the different other focus areas who the agency is, federal, state, and local level. All right, now looking now at road safety research. A lot of things in road safety research, and we need a lot more good road safety research, and that's one of the things why we focus on collecting good data and then analyzing the backside of it, because if we can get good crash modification factors, that helps us in the future to develop better projects. So in road safety research, we want to collect all the data on the people involved, the vehicles involved, the roadway environment, and make sure we're doing the right research to come up with the right countermeasures, to come up with the right safety effects and safety treatments to reduce crashes. So here's some research question examples. What are the characteristics of crashes involving teen drivers? And so what's the safety effect of instituting a graduated driver license law? Where it takes a little bit longer maybe to get your driver's license. It's not just you have to pass the test and here's your license, but you have to spend some time actually learning how to drive, because you don't get it out of a textbook. There is so much more to driving than just what you read in the textbook. You have to really experience on the roadway. And so just a variety of research questions here and some of the different things to be considered and evaluated as we, again, try to do good research. A lot of good agencies out there doing a variety of research. There is so much research going on, and you can see all the different agencies listed on the screen here. Gosh, we're getting close to noon already. So yeah, lots of different agencies doing a lot of research and a lot of sponsored research out there that's really helping to build a culture of safety. All right, quickly into strategic communications. One of the things, if you're going to be implementing these road safety efforts, you need to be communicating with the people that you're intending to communicate with. What are your objectives? Who's your target audience? What's your design message? What are the appropriate channels? I mean, if you're trying to reach, elder drivers or elder road users, they're probably not on, Facebook, or many of them may be, but they may not be on Twitter. And so you want to make sure you're using the right communication channels for the audience you're trying to reach. And so you have to identify what your budget is and then measure your results. Are we effective at reaching out to them? And again, these are the key steps in developing a strategic communication plan to reach the people you're trying to communicate with. A great example in the Tampa Bay area, Bike Walk Tampa Bay. It's a great regional coalition, and they do a great job of really looking at the needs of the bicyclists and the pedestrians in the Tampa Bay area and communicating effectively between agencies of the needs that need to be implemented to make the environment safer for bicyclists and pedestrians in that Tampa Bay region. All right, chapter 16, advancing road safety. Improving road safety certainly is a complex endeavor requiring the knowledge and expertise of a wide range of professionals. Road safety improvement is a joint effort across many federal, state, and local agencies and the private sector. Private sector also is involved. And each of those agencies has their own particular focus and their own expertise areas. To really advance road safety, you need leaders, you need people in responsible positions that can lead and cast vision for others. You need champions. You need people that really encourage the leaders to continue to lead, and people, the champions, really help to push others to excel and go beyond. And you need coalitions and safety partners. There's lots of different people with lots of different interests that come to the table. And all of those people are important contributors to what we're trying to do to make the road safer. As we look towards Vision Zero, the traditional approach to traffic safety has always been to just kind of shrug our shoulders and say, well, traffic deaths are inevitable. What we need to do is perfect human behavior, get the people to act right. Don't drink and drive, don't do this, pay attention. Prevent collisions, the best we can. It's all it's their fault. It's an individual responsibility. The drivers aren't driving right. And, gosh, saving lives is very expensive. That's been the traditional approach. But the Vision Zero approach is something different. Traffic deaths really are preventable. We really can bring down traffic deaths. We can stop these things. We need to think about integrating human failing in the approach, that people do fail, people do make mistakes, but we don't want it to be a fatal mistake. We want it to be something they survive. Okay, I made a mistake. I was driving too fast. I slid off the road, but we don't want them to die as a consequence of their mistake. And so it really takes, an emphasis on preventing those fatal and severe crashes by making crashes more survivable. It's a systems approach. And what we need to really get to thinking about is saving lives really is not expensive. If we plan ahead, if we think about, good design encourages good behavior. All right, so the national strategy is a highway system that is free of fatalities. And that's where we all should be going, is towards zero deaths. That's what we really want to accomplish in all that we do. All right, I've talked a long time. It is now 12 o'clock, so hope won't take you too far away from lunch. But are there any questions?
There's a couple. Before we get to questions, in case anybody has to take off, acknowledging that it's 12 o'clock and respecting everyone's time. Quick announcement: the next webinar is February 18th in 3 weeks. Jack Freeman from Kittleson and Associates is giving us an update on the Highway Safety Manual version 2. So that'll be on the 18th of February. Look for an email from us with that announcement. It is posted on the Tampa Bay Traffic Safety site. And note that that's a Tuesday. We usually have these on Wednesdays. We're doing it on a different day. With that, I'll get to the Q&A. There was a couple of comments, two things. They're not included in the fundamentals of safety, but definitely are worth noting that FHWA has the Safe Transportation for Every Pedestrian STEP training that's specifically for pedestrians. The fundamentals is a little bit more of a high-level overview that focuses maybe a little more on vehicles. So if anybody really wants to get a full view of the pedestrian activity as well, find the manual and the training on that, and also the speed and context classes are critical to the safety evaluations. And we kind of glossed over some of the speed information on here, but there is a speed management manual that DOT has, and there's sections in the FDM with the context classes, and that's a thing that particularly in Florida, because most of our audience is Florida. Excuse me, the DOT here is moving towards using that for all of their studies. I don't know if you have anything to add to those two, Larry.
No, I went to one of the STEP training classes last week, and it's very good stuff. Yeah, they're doing them all over the state. I think they've got a couple this week, and be doing them in South Florida next week, I think. So, the STEP training is very good, and it's really emphasizing, safe transportation for every pedestrian, and it's really looking at how do we make the roadways better for pedestrians. They are, in so many cases, they have been for years an afterthought, and so they need to be a forethought that needs to be thought of beforehand, and not at the last second, oh gosh, we'll throw something up for pedestrians. But early in the design process, all users need to be considered.
Are you aware of any studies available on crashes into non-breakaway signal poles and switching from span wire poles to mast arm poles? Often mast arm poles are placed in the median due to their length limitations, making them too close to the edge of the roadway.
That's an excellent question. I'm not aware of any studies really on that, but it is an excellent question that, the whole clear zone concept, and what do we do with that signal hardware? And that is a really excellent question that the design really should have all the signal equipment outside of the clear zone. And it is something that is so often compromised, if you will, because structurally we we need the mast arms. If you're certainly within the 10-mile area of the coast, you got to have mast arms. And due to the huge lengths of some of the mast arms, it makes it tough to put those things within the right of way. And you're struggling with how much right of way do I need, and can I move this further back from the edge of pavement? It is a really tough design question. Hopefully, as we do build either mast arms or the span wire installations, they should be outside of the clear zone. Typically they're at least 4 feet behind the face of the curb, so technically they're outside the clear zone. But again, if you're 4 foot and 1 inch, that's really no difference from being 3 foot and 11 inches from the face of the curb. And it is much better. The further you can move those things back towards the right-of-way limits you have, the better. But that is one of the real issues that we struggle with in design, is moving those poles further back to create better recovery for somebody that does leave the pavement.
Somewhat related to the clear zone, one that I've been struggling with is, complete streets and context class. Like what you just said is what we've been talking about and teaching forever, that the further away you get all the objects away from the travel lanes, within the right of way, away from the clear zone, the safer it is. But some of the new speed management criteria, or not the criteria, but the speed management countermeasures include introducing, landscaping and basically visual obstructions to make it more uncomfortable for the driver to travel along the roadway, which in turn reduces the speed, which in turn reduces the severity of the crashes. So it's a little bit of a kind of seeming inverse proportion relationship between the wanting to get things away from the roadway, because then that leads to more speed, because it looks like a highway, right? So I've been kind of wrapping my head around suggesting in road safety audits, like, hey, we need to get things closer to the roadway.
Yeah, I mean, that has always been one of the tough things, and you're absolutely right. You move things so far back from the roadway to make it safer, and well, it feels safer, so I can drive faster. And it's one of the tough things we struggle with, in that we want to encourage people to drive slower on many roadways. And how do we do that without endangering their lives? and so, yeah, we've got to use a lot of different things. I mean, you pull some signs in closer to the roadway, because the sign bases are frangible. They will break away and not cause you to lose your life when you hit the signpost. But move things that are frangible, even if they're things people don't want to hit. Maybe that's what we do, is do a lot more of those kind of things, where we put things out there that aren't going to kill you when you hit them, so that you don't leave the roadway and hit the things that will kill you when you hit them. It's the tough struggle we face, because again, the safest thing is, widen the roadway, widen the clear zone, and move things far away. But we also have to encourage people to drive slower, and so that means change the environment.
Do you have any thoughts on Florida HB 1371, the proposed bill that's going to make it so that yellow lights basically go away at crosswalks? Everything has to be a red signal or eliminate the crosswalk?
Well, the real basis behind that, it was a fatal crash involving a young lady over in Brevard County. And I mean, in my opinion, it's an overreaction to what is an unfortunate situation. I think what happened was, there's been so much good publicity about RRFBs, the rectangular rapid flash beacons with yellow, that people think, wow, this is the greatest thing in the world. Let's put RRFBs all over the place. And it's just like roundabouts. I mean, I like roundabouts, but I think about roundabouts or RRFBs as they are one tool in the toolbox. and we got to make sure we put the right tool in the right location. I can tell you, personally, I have driven a nail with a pair of pliers, but that's not the right tool for that job. And it's the same thing. If we put a roundabout where it doesn't belong, we're not going to get the safety performance that we expect. Same thing with a rectangular rapid flash beacon. If we put that in a place where it doesn't fit, we're not going to get the safety response. And so what happens is if you put a RRFB with the yellow flashing lights in a high-speed location, the people that are driving in that high-speed location, and I've been to some of these, I've done road safety audits at some of these kind of locations. At a high-speed location, you see a flashing yellow light, and you really don't see the conflict yet. You're too far away. You don't see the person that's about to enter the crosswalk. And you really, on a high-speed rural location, you're not expecting to stop. You don't have an expectation that, oh gosh, there's going to be a conflict, because all of the roadway environmental features say it's high-speed road, I get to go. And so when suddenly there is a conflict, the physics takes over, and you don't have enough distance to physically stop, because the stopping distance goes up with the square of the speed. So if you double the speed, you need 4 times the distance to stop. And the problem in some location, they put RRFBs where they really physically don't fit, just because the physics breaks down. And like I said, what I think in this legislation that's proposed, it's based on an RRFB that maybe should not have been there. It was a high-speed location, or I think my understanding is it was a higher speed location. And again, the vehicle versus human interaction didn't have the right amount of physics and time to work there. And so again, RRFBs, I think, work very well in low-speed applications, but in higher speed applications, we need something else.
Yeah.
And so
I agree.
yeah,
I would be sad if RFPs go away because of, maybe them being implemented in places where they should not be. Just update the criteria.
yeah. I mean, it was one of the things many years ago when RFBs first came out. A friend of mine down in Miami was telling me they put one in a downtown area of Miami, and people weren't obeying it. I mean, they hadn't done any education or outreach ahead of time. And people were saying, well, it's a yellow light. I mean, it's just like any other flashing yellow. I just go. I mean, people were just ignoring it, not thinking about it being a warning that I might need to stop. And so it's been an ongoing thing. And in talking, like I said, I was at one of those STEP training classes last week. The feds are actually thinking about, well, maybe the red RRFB isn't a bad thing to at least experiment with. So nationally, we may at least look at that.
Yeah.
It's an interesting discussion. Yeah, I mean, I think the DOT hopefully is going to respond to that bill and say, well, maybe that wasn't the best location for an RFB. Maybe a hawk should have been implemented there. And again, at those higher speed locations, something like the hawk or something else rather than an RFB is the appropriate tool.
Maybe we're over time already, but if let's do one more. Any thoughts on autonomous vehicles with regards to kind of this whole safety world that we live in?
Well, for years, I've been the autonomous vehicle skeptic. I've done a few presentations on the autonomous vehicle as a skeptic. And my main skepticism is the technology is not reliable enough yet. I mean, I think eventually, if we get the technology more reliable, it will help. But currently, ITS sensors are only spec'd out to be 90% reliable. That's the specifications, 90% reliable. That's not good enough for me to let those sensors drive my car. And so we need to get a whole lot better in terms of the reliability of the sensors. And then, it opens up a whole lot of other questions. If we add a lot more sensors into the roadway, who's going to maintain them? Who's going to operate them? Because all the agencies I know of are scrambling for money and scrambling for technicians and people to go out there and maintain all these devices. And so if we're going to add more devices, that's a lot more stuff and expense to maintain and keep them operating. And if the vehicles are needing that data coming from the infrastructure, we have to have good, reliable infrastructure. And like I said, every agency I know of is scrambling for, I need more money to operate and maintain this.
So Back to the Future is set in 2015. I mean, we kind of missed the flying cars, but the Jetsons is actually set in 2062. Do you think we'll have it set by then?
I don't know. In 2062, I'll be 100 years old, so I probably won't be here. But we've got a long way to go, and I hope we come up with some other changes and challenges. Because I mean, part of when you think about the Jetsons, traffic control in 3 dimensions, certainly you can stack multiple cars on top of one another, and so it should be free flow. But then when you get to that type of free flow conditions, speeds are going to go up, and again, physics takes over.
Well, let's hope we can figure it out in the next 42 years. I think that's probably a good place to end. Thank you so much, Larry. The information was very beneficial. There's a lot of kudos and thank yous in the chat.
Okay.
We'll go through the chat later if there were any questions that weren't addressed, because we're well over time now. We should probably go ahead and let our audience go. We'll end the recording now, and we'll follow up via email with anything else. And if you have any questions, any additional things for Larry, his email is up on the screen there, Larry at HagenConsultingServices.com. And again, the recording for this webinar will be on the Tampa Bay Traffic Safety site. And we'll see everybody back on the 18th to learn about the version 2 of the Highway Safety Manual.
All right, and also don't forget to send in your PDH forms. Again, my email address is there on the screen. And yeah, the PDH form is there in the download pod. Just download that, fill it out, and send it in.
Okay, thank you.
All right, thank you all.